Chapter 2, Atoms and Elements. Think about graphite. If you're writing with a pencil, your pencil lead is made out of graphite. There's no lead in pencils. What if you took a piece of the graphite from your pencil and you cut that in half, and you took one of those pieces and cut it in half, and then you took that half and cut it in half, and let's say you have the ability to see really, really small things, and you have a super sharp knife, and you're able to just keep doing that indefinitely? Could you just keep doing that forever? Or would you come to a point where you couldn't cut it in half anymore?
Not without causing a fission reaction.
Pardon me?
Not without causing a fission reaction.
Ah, very good. Not without causing a fission reaction. And you couldn't cause a fission reaction with a knife. Eventually, you would get down to an atom, the smallest piece of matter that cannot be broken outside of nuclear reactions. If we think about Lego bricks, have any of you been to Legoland in San Diego? It's really, really cool. They have this boat ride, and you see all these wonders of the world recreated in Legos. So there's Mount Rushmore made out of Legos, and there's this guy with a giant Q-tip cleaning somebody's nose. It's really funny. So take that big sculpture, and it's probably like 10 feet tall at least, made out of Legos entirely. And if you start taking that apart, you can take it apart and take it apart, just like cutting the graphite, right? Eventually, though, you're going to get down to individual Lego bricks. Can you break those with your hands? No, you can't. Now, if you got out a bandsaw, could you saw a Lego in half? Yes, but that's like nuclear chemistry. That's extreme force. But just with regular, you can't break Legos. You can't break atoms with chemical processes. So we end up with individual carbon atoms breaking down the graphite. The word atom comes from the Greek word atomos, which means indivisible. And atoms are what compose all of matter. They're the building blocks. To understand matter, we have to understand atoms, and that's what we're going to work on in this chapter, is understanding the atoms. Back in the 1980s, Binning and Rohrer at IBM in Switzerland did some work that led to the development of a technique called scanning tunneling microscopy. And this is really a neat technique because there's a limit on optical microscopes as to how small of an item we can actually visualize and see. And this allows us to see things that are too small, even for very, very powerful optical microscopes. So they use this electrode tip. It has a very, very delicate pointed tip. And they pass an electric current from this electrode through empty space to the surface that's being looked at. So the surface has to be something that's electrically conductive. By monitoring the current, which is related to the distance of that gap, they can move the electrode tip and keep the distance from the surface constant. And so if they come over this way and there's a little bump, the changing current tells them they have to lift it up. And so this is all computer controlled, and they scan this back and forth over the surface being examined. And from the position of the tip, they can generate a virtual picture of what's being looked at. And these are the sorts of pictures we get from STM. This picture is of iodine atoms shown in green on a platinum surface. So we can see individual atoms. This is really, really amazing. And then, of course, scientists have to have some fun with this. You can actually use this technique to move individual atoms and spell words and things with them. So here they've taken iron atoms, the reddish purple, on a copper surface, and they've moved it and used the Japanese kanji characters to spell the word atom in atoms. Scientists do have a sense of humor. It's just kind of a little warped. So in spite of the incredibly small size of atoms, they are the key to relating this microscopic world, something that needs to be seen through a microscope, with the macroscopic world, which is stuff we can see with our eyes. The atom is the smallest identifiable piece of an element, and there are many elements. There are 91 elements that occur in nature, and there are a bunch more that have been made in laboratories, so they're synthetically made. In fact, I think it was just a week or two ago, they gave official names to about 4 more of these man-made elements. So we have a big periodic table here on the wall. And you'll notice that some of these elements, their symbols are just outlines. And others of them are blue or red or black, and the symbols are filled in. The ones with the filled in symbols are naturally occurring, and the ones with the outline symbols are man-made.